This video is going to be another direction I'm looking to expand my channel into. It's definitely a little bit inspired by Wrath of Math, because like a side hobby of mine was tutoring little students and then just seeing how they progressed and developed, and I kind of missed that. I was looking forward to getting that here soon in the sense of teaching a little one, but I'm gonna have to wait just a little bit longer. As far as the markets go, when you're doing the investing, you really just need to do your evaluations once every 3-6 months, maybe even a year, and then you're just watching paint dry the rest of the year. Unless we're talking crypto, then you can kind of just pull the numbers right out of your... Alright, now let's get into that topic at hand. So today's question, courtesy of Reddit, is how many different ways can we write a string of letters that contains 4 A's, 7 B's, and 3 C's? This student had a good approach in how they were attempting to solve it, in the sense of 14 choose 4, and then they knew there was going to be too many solutions, so they tried dividing out the 10 choose 3, and then they ultimately got up to a total of 1,121 combinations. But then they're not sure if it's too high or too low, and in this case it's too low. But we'll build up to that here in a second. So let's switch over to the whiteboard now. Alright, here we are on the whiteboard now. And just to make sure that we're all on the same page, we need at least a little understanding of what factorials are. And factorials, simply put, if you see a factorial, you'll see a number and an exclamation mark. So for instance, we could do 5 factorial. What this means is that we're going to take 5 and we're going to multiply it by every number less than it up until we get to 1. And in this case, this would be equal to 120. So if I gave you 3 factorial, you would do the same, and you'd have 3 times 2 times 1, and that's equal to 6. All right, let's erase that out of here now. So a technique that I like doing for these problems that we know that are going to get into a big number and they might be harder to solve for us outright at the beginning is to simply look at a smaller case, see if we can understand what's going on with the problem, and then build up to it eventually. So what we're going to be looking at here is if we eliminate all those extra numbers and we're just looking at a singular case. So if we've got 1A, 1B, and 1C, is it possible to write up all the different combinations we've got for these 3 letters? And I would argue I actually just did it right there. So we've got 6 different possibilities. And remember, that was 1A, 1B, 1C. And there was the important thing that I brought up at the very beginning of factorials, because we're going to need them for this problem. Is there a way that we can write 6 as a factorial? And if you said yes, you literally just did it a minute ago, you're correct. It would be 3 factorial. Actually, I can get rid of that arrow. They're equal. All right. So we have at least a bit of an understanding of what we're working with here. Now let's see if we do a couple of the extra letters. So in this case, let's get rid of all the A's. We won't need them for this one. We'll get rid of all but 1B, and we'll leave our 3 C's. So in this scenario, can we once again write out all our possible combinations? And if you said yes, of course we can. It's not going to take too long. And then, so that was B moving through. And then we're going to put a C. And then we're just going to move him through as well. So we'll do, actually, he's got to move in, right? So B, yep. And we're going to move him in one more. And then we're going to move him in one more time. So there we go. And if you noticed, these three are all exactly the same thing. Along with this one's already accounted for. This one already here is already accounted for in our list. So all of these are redundant. But I will say, if our C's were unique, such that, think like a C1, C2, and a little C3. How many ways could we rearrange these three C's, and how many solutions would that get us? And if you said once again, we literally just saw you do that a minute ago, and there's 6 ways or 3 factorial, I would say yes. Good, keen observation. And if I asked you the same thing as well, this one's going to sound a little goofy. I'm just going to put this equation up here, though, in the meantime. If I asked you how many ways can you rearrange a singular B? So if I add you to shuffle that B around, I give you one B and I say, hey, mix that up, and then show me that B. How many ways can you do that? I wanted to make sure that I give a visual representation of what I meant by, like, if I hand you a B and I ask you to shuffle it up and give it back to me. And I've borrowed one of my wife's little tarot cards. It's got the little emperor kitty on it, but it's just going to represent our B in this case. So if I handed it to you and asked you to shuffle it up, you would think this is kind of crazy, and once again, you're right, because you've got one card that you're just going to kind of shuffle around, and I'm like, okay, hand that back to me. You would just give it back to me, and it's still the same card. Therefore, it's just showing how there's only that one solution there. If you said 1, you're almost correct, because I was looking for 1 factorial, which is 1. But remember, we're thinking in factorial here. So we know that these are our 4 solutions for this problem. And now I'm going to ask, can we write this 4 as a factorial? And while it might not be easy to see at first, if you do, let's see, this 4, we'll do 4 factorial. And then we do a 3 factorial underneath, and then multiply that out by 1 factorial. Well, this 1, it becomes irrelevant, so we'll just end up, and actually, let's peel a 4 off of this 4 factorial here. So we'll do 4, and we'll do a 3 factorial over 3 factorial. Cross these off, and we just end up with 4. Now, hopefully, you're starting to see a pattern develop, and then this problem is not nearly as hard once you see it. So let's get rid of all these bad boys again. And let's do the opposite, just as a little bonus case. So we'll say 7 B's and 1 C. That would get us an 8. Oh. And then, so how many ways could we arrange these 7 B's amongst themselves? And if you said, so think like B1, B2, so on and so forth up until B7, and rearrange all those bad boys amongst themselves. Well, if you said 7 factorial, I would agree with you. And once again, if we had a singular B, or no, a singular C. So if I gave you 1 C, and I told you to rearrange it amongst itself, how many ways can you rearrange that bad boy? 1 factorial. Cool. And then since we had 8 letters, 8 factorial divided by 7 factorial. times 1 factorial. Or that's all a very convoluted way of saying 8. Hopefully you see the pattern now. And we can just go straight to the end here. 4 plus 7 plus 3. 14. How many ways can we arrange? Yeah, we'll say the 3 C's. Let's start there. So the rearrangement on our C's, C1, C2, C3. Well, we've already done that multiple times at this point. Rearranging 3 things, it's 3 factorial. Same with the B's, B1, B2, so on and so forth, B7. How many ways can we rearrange those? If you said 7 factorial, spot on. And the same with our A's. So A1 up until A4. If we rearrange those, get 4 factorial. So now, in the numerator, if you're thinking 14 should go there, I would agree with you. Along with, now we need to remove all those little duplicated mixes of our certain letters. So we know we've got, coming from, let's do left to right. So coming from the A's, we've got a little 4 factorial in there of how we can mix them all up amongst themselves. Same with B, we've got 7 ways that we can mix them up. Or 7 factorial ways, sorry about that. And then 3 factorials on the C's. So this whole thing is going to be our answer. We'll go ahead and punch this number into the calculator now, and it comes out to just slightly more than 120,000, which is only a little bit bigger than 1,200. Now, if you made it to this point in the video, if you could, leave a like, leave a comment. I know for sure my editor's going to have a lot more work coming his way, so let's at least give him some encouragement. Thanks for watching.